And here's questions 3, 4, and 5 in our homework set 41. Question 3, let's see what we can do to solve this system. Now I'm going to start by naming these equations. That'll be number 1, this will be number 2, this will be number 3. Now let's look at this system and decide. Remember what we're trying to do is we've got 3 by 3. We want to use some kind of elimination to eliminate one equation, one variable, and reduce the 3 by 3 down to a 2 by 2. So let's decide on a variable to eliminate. Now it doesn't matter which one, eliminate x, y, or z. Why don't we eliminate y? Or, we've eliminated y and we've eliminated z. Why don't we eliminate x this time? All right, so here's the plan. I think we should eliminate x using, okay, now it doesn't matter, we just need a pivot. So how about if we pivoted on 1 and 2 and then 1 and 3? All right, so I'm going to use 1 and 2, then 1 and 3. So let's see what happens. So with 1 and 2, now look at equations 1 and 2. I'm eliminating x. So I want to have these coefficients to be opposites. Right, so the smallest number they both go into is 12. So I'm going to make them 12s. So how about if I do this? I'll multiply. They have the same sign, so I need a negative multiplier. How about if we multiply the top equation by negative 3? So here's what my plan is. Negative 3 times equation 1, and then plus 4 times equation 2. Does that do it? Multiply this by negative 3, I'll get positive 12. Multiply this by 4, I get negative 12. So let's do it. Multiply everything in here by negative 3. So how about negative 3 times negative 4 is positive 12x. Then negative 3 times negative 2 is plus 6y. And then negative 3 times negative 2 again is plus 6z. And that's all equal to 3 times 0 is 0. Now, maybe you already saw this, but you look up here in equation 1. Couldn't you just divide everything by 2, get those numbers smaller? And in fact, what about equation 3? Divide everything by 4. All right, but we already have it here. So this is a new equation. I'll call this equation 4. Now, let's use 1 and 3. All right, I used 1 and 2. Now let's use 1 and 3. So I got 4 and an 8. Okay, I can turn them into 8. So all I have to do is multiply this by 2. But I wanted the opposite sign. So how about negative 2? Negative 2 times negative 4 will give me positive 8, and then that will drop that one out. All right, so that plan now is this. Negative 2 times equation 1 plus equation 3. It'll look like this. Multiply everything through here by negative 2. It will be positive 8x, positive 4y, positive 4z equals 0. And then equation 3 is negative 8x minus 4y minus 4z equals 0. Oh, look at this. You see what happens? The x's are gone, the y's are gone, the z's are gone. So I get 0 equals 0. All right, so I've eliminated all the variables, and I'm left with a true statement. Okay, that means that I have this. Infinitely many solutions. All right, now in terms of how we're going to write this, this means this system here is dependent. So getting an actual solution depends on our getting more information. All right, we thought we had enough information to solve this when we set it up from the application, but apparently we don't. So this is a dependent system. That occurs when you eliminate all the variables and get a true statement. Now, if you eliminate all the variables and get a false statement, then it's an inconsistent system. There'd be no solution, and your system is inconsistent. That means when you translate it from the application to the symbols, you've got some data went wrong somewhere. Well, it is an interesting system, right? I have equations 1, 2, and 3. Now, there's only 2 variables in each equation, but you still have all 3 variables. x, y, and z. So it still is a 3 by 3 system. Here's what I think I'm going to do in this case. You see that first equation, x plus y equals 9? What if I just solve equation 1 for x? Solve equation 1 for x. All right, that'll give me this. All right, so here's the equation. X plus y equals 9. Now, if I solve it for x, I'll get x equals 9 minus y. All right, so that's what x is. Now, what I'm going to do is I'm going to put that x, where's the other x? Right here. I'm going to put that x into equation 3. So here's what I have then. All right, here's equation 3. X minus z equals 7. And if I put this in here, I'll get 9 minus y minus z is equal to 7. Now, let's do this. So I'll get negative y minus z is equal to 16. All right, that's a new equation. I've got 3 equations. I'll name that one 4. Now, this equation has a y and a z. Look back up here. Equation 2 has a y and a z. So how about this? Here's a new system. This is y plus z. That is equal to 2. Now that's equation 2, right? And then I got this new one. Negative y minus z is equal to 16. That's our new equation 4. Look what happens when you add these together. The y's are gone, the z's are gone, and I get 0 on this side equals 18. Well, I've eliminated all the variables, but I got a false statement this time. All right, now that implies there is no solution, but what we say is that this system is inconsistent, which means if we had an application and we were converting the application into this system, maybe some of the data was wrong or we did something, we made a wrong translation. But the way it's written, there's no solution here, so things are inconsistent. Question 5. Now this is similar to question 4 in that we have 3 equations, 3 variables, x, y, and z, but each equation has only 2 variables. I'm going to start by naming these equations. That'll be number 1, middle one number 2, bottom one number 3. Now here's what I'm going to try. You see that first equation? I can easily solve this for y. So what I'm going to do is this. I am going to solve equation 1 for y. All right, that'll give us that. Now here's the equation. 4x minus y is negative 2. So y is negative 4x minus 2. Now I'm going to take that 4x minus 2 and I'm going to put it into equation 2. Put this into equation 2. Now that'll give me this. Here's equation 2. Y plus z is 0. But y is this right here. So negative 4x minus 2. And then plus z, that's equal to 0. So I can do this. I'll get negative 4x plus z is equal to 2. Now that's a new equation. I'm going to call that equation 4. Now this equation has an x and a z. And I notice up here, equation 3 has an x and a z. So if I write equation 3 here, which is 6x minus z, that's equal to 3. Now, oh, I'm lucky here. If I just add these together, if I just add them together, negative 4x plus 6x is 2x. The z's are gone, and this is equal to 5. So x is equal to 5 halves. All right, so I know what x is. Now, I know what x is. If I take that x, let me do it this way. If I take that x, that 5 halves, now follow it all the way up to the top. If I put that right in here, I can get y. Right, so here's what I'm doing. I'm going to put this into equation 1. So here's equation 1. I'm up at the top. Equation 1 is this. 4x plus y is negative 2. But x, I know now, is 5 halves. Plus y is negative 2. All right, the 2 and the 4 will go twice, so I'll get 2 times 5 is 10. Plus y is negative 2. And then subtract, I'll get y is equal to negative 12. Now, I've got x and I've got y. All I need is z. All right, so this equation here, the second one, looks like it's the easiest place to get z. Why don't I put that negative 12 in for y here? All right, so I'm going to put this one into equation 2. So it's a matter of just a lot of substitution. Here's equation 2. Y plus z is equal to 0. But y, we know, is negative 12 plus z is 0. So we'll add. So we'll get z is equal to 12. All right, so here's our solution. X is 5/2. Y is, where'd y go? Negative 12. And z is positive 12. And that is the end of homework set 41.